All right. Good morning, everybody. So let's pick up where we left on Tuesday. Okay. So as I told you on Tuesday, we will not have in-class assignments today. Okay. So we will resume next week. So from now on, I will make the recordings available and that will be posted on Canvas. And then if you want to go back and watch the lecture again, you can do that, okay? All right, so with that being said, let's move on to the science. So we are talking about chemical reactions in aqueous solution, specifically acid-base reactions. So I would like to go back a little bit and make sure we understand what we are doing before we move on. So to do that, I will show you a slide that unfortunately is not available on Canvas, but I can make it available after the lecture today. Okay, so let's go back and make sure we are all in the same page. Okay, so I would like to show you what happens when phosphoric acid is dissolved in water. Barium hydroxide is happens what happens when barium hydroxide is dissolved in water, and then the reaction between phosphoric acid and barium hydroxide. Okay, so let's follow some steps to make sure we get to the right answer. For some reason, your textbook shows the concepts in a weird order, and I cannot talk about structure at this point because that will show up on chapter number 8. But for now, let's just take a look at the structure of the phosphoric acid to try to make sense of what happens when we dissolve phosphoric acid in water. Okay. So let's start here with phosphoric acid. The first thing you have to remember is the formula of the phosphoric acid, and that's going to be H3PO4. Okay, so this has to be on the top of your head. Okay? If it's not on the top of your head, let me tell you what is going to happen. You will try to look it up, which is fine, but doing that you lose time, and time is very precious here in this class. Okay, okay. Formula of the phosphoric acid is H3PO4. This is a covalent compound. Okay, so that means there are electrons being shared among the elements. And the structural formula of phosphoric acid is the one I am showing right here. Okay, we have a phosphorus as the central atom, and each solid line means that there is a pair of electrons being shared. Okay, notice here that we have hydrogens bonded to oxygens in three different positions, okay? And that's the meaning of the H3PO4 formula. We have hydrogens bonded to oxygens, okay? This is not an ionic compound, okay? H3PO4 doesn't mean that we have this sort of formula, okay? This is not an ionic compound. According to Arrhenius, any acid, when dissolved in water, will release H+. Okay, so now let's take the phosphoric acid and dissolve in water. The water is strong enough to break the hydrogen-oxygen bonds. So it's going to break here, here, and here, okay? So water breaks hydrogen-oxygen bonds. And the result of the dissolution of the compound in water is the production of H plus what was left, which is PO4. Now, don't forget about the charges. We have here PO4 is always 3 minus. To balance the 3 negative charges, we need to have 3H plus here. And that's what happens when we dissolve phosphoric acid in water. You release H plus and then the anion of what is left. The number of hydrogens that are released, the number of H plus formed, is exactly equals to the number of hydrogens that we have in the formula. All right? So careful, you have to represent as H plus. If you write something like that, that's telling me that you have formed a compound with this structure, and this is not possible, okay? Always release the hydrogens as H plus, okay? This has to be clear to everybody. Okay, so now let's move on to the base. Okay, the base that we are dealing here is barium hydroxide. So we have to remember the formula for barium hydroxide. For bases, first element, and that is followed by OH. The number of OH units present in the formula is going to be exactly equals to the magnitude of the positive charge of the cation. Barium belongs to the group 2, and because of that, the charge is always going to be 2 plus. Therefore, we have to indicate here OH2. Okay, so for barium hydroxide, we have BaOH2. And now for this compound, we are talking about an ionic compound. Any ionic compound is formed by a cation and an anion. We always represent the cation first and the anion followed uh, by the cation. Okay, so we have here barium 2 plus, and each hydroxyl is 1 minus. Okay, note here that the charge, the net charge is 0. When we dissolve this compound in water, if the compound is soluble, the water is going to be strong enough to split positive and negative charges. Okay, so that will produce barium 2 plus dissolved in water and hydroxyl ions dissolved in water. Okay, attention here. If we have two hydroxyls before, we have to have two hydroxyls after. Okay, the water is only capable of splitting the charges. Okay, the water cannot break the bond between oxygen and hydrogen, only split the charges. And that's what we are going to form in water.
I have a question.
Yes,
Can you give any insight as to how to quickly identify the difference between a covalent and an ionic compound?
yes, of course. So let me write down here. Okay, so let's start with ionic. Okay, ionic compounds, you always have to have someone losing electrons and someone gaining electrons. So basically, the positive or the cations will be anyone from group 1 of the periodic table, group 2, or group 3, or ammonium. Okay, so those are going to be your cations. And your anions are going to be anyone from groups, oh, sorry, here 13, group 15, 16, 17, or hydroxyl. Okay, so every time you see a compound that's formed by a combination of these two groups, this is going to be an ionic compound. Okay. Ionic compounds are usually salts, bases, or oxides. On the other hand, the covalent compounds, in this case, both elements are looking for electrons, so therefore we don't have charges, okay? And it's going to be formed by a combination of elements from groups 14, 15, 16, 17, and even 18. Okay. Covalent O and, sorry, here, hydrogen. Okay. That's important. In this case, you have covalent compounds, and they are usually going to be oxides as well, acids, or what we call molecular compounds. Okay, so let's give you an example. When we look at H3PO4, this compound is formed by hydrogen plus phosphorus, which belongs to the group 15, and oxygen that belongs to the group 16. Okay. So see here that all the elements here are looking for electrons because they have more than 4 in the valence shell. Therefore, they have to share electrons to achieve the stability. And that's the characteristic of a covalent compound.
Thank you. That helps a lot.
Okay, yes, no problem. Okay. Is that clear for everybody all the way to this point, how I got the products when I dissolved acid in water or base in water?
I have a question. So the
Yes.
solubility is determined by that chart you gave us, right?
Yes.
Okay.
Yes. So that's my next point.
Okay, cool. Thank you.
Okay. So uh, I'm really sorry because I have to follow the order of the book, but there is a reason that some compounds are soluble and some compounds are not soluble. But at this point, we have to use the table. Okay, I'm really sorry about that. Okay, so now that we know what happens with phosphoric acid when dissolved in water and barium hydroxide when dissolved in water, that's 50% of the problem. Okay, so now let's react both compounds and see what happens. Okay, so that's going to be my third step here. And always start with the molecular equation, because that's the easiest way to get to the result. Okay, so let's follow here some color code. Okay, so now let's react phosphoric acid. We know that phosphoric acid is H3PO4 with barium hydroxide right here that we know that is BaOH2. Every time you react an acid with a base, your products have to be salt and water. Okay. So let's react that. So I'm going to write one of the products here that we are always sure about, which is water. For the salt, you always have first your cation, which is always the one that comes from the base. So therefore barium, and we know that's a 2 plus, followed by your anion, okay? And that's always whatever is not hydrogen from the acid, which in this case is PO4. And we know that the charge is 3 minus, okay? So the trick here for the charge of the cation is to look at the number of hydroxyl ions, and for the charge of the anion, you look at the number of hydrogen atoms from the acid. And that's how we know that we have the number of the charge that we have, okay? So the problem is almost solved. So now the next step is to cross the charges in the salt formed. So let me rewrite here the formula down. Crossing the charges, we have Ba3, and we are going to multiply the whole phosphate unit by 2, okay? PO4 2 plus water. All right, next step. Now let's determine if the salt is dissolved in water or if it is a precipitate or a solid. So we go back to the solubility tables, look for phosphate. Phosphates are always insoluble. The exceptions are when it's bonded to group 1 or ammonium, which is not the case here. Therefore, we know that this has to be a solid, okay? Other ways to indicate that you formed a solid is to use an arrow pointing down, and that's more than clear that this compound is not soluble in water. Okay, so that means when you mix a solution of phosphoric acid and barium hydroxide, you will end up with a solid. Okay, and the identity of the solid is Ba3PO42, which is called barium phosphate. Okay, at this point we are almost done. To get the 100% score in the exercise, now we need to balance the equation. On the product side, we have 3 barium. That means we need to have 3 in the reagent side. And here on the product side, we have 2 phosphate groups. So let's add a 2 here on the reagent side. And finally, we balance the water, okay? So we have 6 hydrogens plus 6, that's 12. We have to have 12 on the other side, okay? And the oxygens, they need to match as well. So if you got all the way to this point, that's perfect, okay? That means you got everything, okay? So everything starts knowing the formulas and the names, dissolve them in water, then react them. You have to form always a salt plus water. Do not forget the charges and crossing the charges, okay? Verify if the compound is a solid or not. So that means if the compound is soluble in water or not, and then balance out the equation. If you did that, then you will not have any problems.
Will the reaction not occur if a precipitate isn't formed?
That's a very good question, Katie. So we are always looking for a visual clue. The formation of precipitate is the easiest one that you can have. However, there are other signs that the reaction occurred. For example, if there is release or absorption of heat, that indicates that the reaction occurred, or change in the conductivity of the solution, for example, or change in color. All of those point to some sort of reaction that occurred. Okay? So we are always looking for something to change or something to happen. And that gives you the hint that the reaction occurred.
Okay, thanks.
Yeah, no problem. Okay, so now let's move on from the molecular equation to the overall ionic equation. In the overall ionic equation, the idea here is to represent the ions dissolved in water and make the reaction using the ions, okay? So it's basically the same thing as the molecular equation, but now we are going to use ions. So the trick here is to start with the compounds. So let's start with H3PO4. And let's first represent what happens when we dissolve H3PO4 in water. Because this compound is an acid, it has to produce H+, plus whatever is left that's not hydrogen. Okay, PO4. That's everything that was left. The number of H+ produced is the number of hydrogens that we have in the formula. Therefore, 3+. See here that I have 3 positive charges. They need to be balanced by the PO4. Therefore, there is only one option to balance the 3 positive charges, and that's having 3 negative charges. Now that this compound is dissolved in water, we have to represent here AQ and AQ. And we do the same thing with the base. Let's start here, BaOH2. Let's dissolve that in water. We already saw that we are going to form barium plus hydroxyl. The number of hydroxyls is equals to the number after the parentheses, therefore is 2. See here that now I have 2 negative charges, therefore we have to have 2 positive charges to counterbalance. Now those ions are dissolved in water, so we have to represent here AQ and AQ. So when you have the ionic equation, maybe it will make a little bit more of sense why barium combines with phosphate and hydrogen will combine with OH-. Remember that there is very low probability of 2 ions with the same sign to combine because of electric repulsion. Therefore, positive will look for the negative, forming here barium phosphate, and the H plus will look for OH minus, forming HOH, which is the same thing as water. Okay, and this is going to be a liquid. And we know from the molecular equation that we have Ba3 and PO4 2. And we know that this compound is a solid. It does not dissolve in water. And then you can use the same coefficients that we got from the molecular equation. Okay, so here is a 3, then becomes a 6, 2, and 6. Okay, you can recycle those. Okay, an important thing that I need to highlight here. If the salt is not soluble in water, no ions will be formed. Okay? If the compound is not soluble in water, no ions will be formed. Okay? So we will not find this salt as barium 2 plus phosphate 3 minus. Okay? The water is not strong enough to break the interaction between barium and phosphate. This compound will remain as an unit in water, and you have to represent them as an unit. Okay. At this point, we are almost there. So now let's write the net ionic equation. For the net ionic equation, we are going to treat the chemical reaction as a mathematical equation, which means everything that shows up in the product side and the reagent side can be canceled, will disappear. So let's start with H plus. H plus shows up in the reagent side, but does not show up in the product side. Therefore, we cannot cancel. So we have to write it again. Now pay attention here. Phosphate by itself shows up in the reagent side, but does not show up by itself on the product side. What you have in the product side is phosphate combined with barium. So they are not the same thing. Therefore, cannot be canceled. Okay? So we have to rewrite here. The same thing goes for barium, 2 plus. It shows up by itself on the reagent side, but not by itself on the product side. What you see on the product side is barium combined with phosphate. Therefore, they are not the same thing. Okay? So we have to keep it. And finally, hydroxyl shows up in the reagent side, but does not show up in the product side. Okay, what I'm looking for is the same thing, exactly the same thing. And we don't see that. Therefore, we write again in the net ionic equation and then repeat everything that we have in the products because nothing can be canceled. And for this particular case, the overall ionic equation is the same as the net ionic equation. Did you understand what I did? Do you have any questions? Okay, before we move on, do you need to do one exercise as practice or should I move on with the lecture?
Yes, please. One exercise.
As practice?
Yes.
Okay, so let's do one thing then. Let's take a 5-minute break and then I will prepare the slide really quick here and then post to you, okay? So we will get back at 11:40. Okay, so let's get back here. So let's do an example. So I will give you about 5 to 10 minutes. Try to do by itself, and then we will do it together. For this practice, let's see here. Okay, so let's work with sulfuric acid and calcium hydroxide. First, write the reaction between sulfuric acid and water, what happens. Same for calcium hydroxide. And then the reaction between sulfuric acid and calcium hydroxide. And for that, I would like you to show me the molecular equation, overall ionic equation, and net ionic equation. Okay, so let's do that. Okay. Okay, tell me, where are you at? Do you need a little bit more time, or can I start solving it?
A little bit more time.
Okay. Okay, so let me start solving it. Uh, and then if you have any questions, just let me know, okay? So let's start with sulfuric acid in water. Okay, start writing everything you know about sulfuric acid. The first thing that needs to come to your head is the formula for sulfuric acid, which is H2SO4. Okay? Sulfuric acid is formed by hydrogen plus two elements from the group 16. Therefore, this is a covalent compound. Okay? So all the elements are sharing electrons to achieve stability. It doesn't matter at this point, but the structural formula for sulfuric acid is the one that I'm writing here. Okay. And we see here that the two hydrogens are bonded to oxygen. And the fact that the hydrogen is bonded to oxygen makes this OH bond weak. Okay. Weak bonds may be broken by water. Okay. When we dissolve sulfuric acid in water, the bond between oxygen and hydrogen will be broken. See here that I'm releasing hydrogens in the form of H plus, and what is left is everything that's not hydrogen from the structure. Okay. In this case here, sulfate. We have two hydrogens in the formula of sulfuric acid, so we need to release two H plus. Now we have here two positive charges. We have to counterbalance the charges with two negative charges that must be on the sulfate ion. And that's what happens when we dissolve sulfuric acid in water. Okay. Obviously, the release of the two hydrogens are different steps, but at this point, let's consider that all the hydrogens are released in a single step. It doesn't matter for now. Okay, so that's what happens when we dissolve sulfuric acid in water. We create H plus, not create, we produce H plus and sulfate. Now let's do the same thing for calcium hydroxide. Oh, I forgot to change here, sorry. Okay, let's dissolve calcium hydroxide in water. calcium hydroxide. This is a base because you have hydroxide in the name. Therefore, the formula is always the first element in the name, followed by OH. The number of hydroxyl ions is equals to the number of the group for the metal. Therefore, we have to have 2 hydroxyl ions because calcium is 2+. Okay. Now, we have here calcium hydroxide, and that's a solid. Okay. Calcium hydroxide is formed by group 2 plus OH minus. Therefore, this is an ionic compound. Okay. We have cation and anion. When we dissolve an ionic compound in water, if the compound is soluble, the water is going to be strong enough to break the interaction between cation and anion, and that will produce calcium and OH minus. We started with 2 OH, we have to finish with 2 over here. Now look at the charges. We have 2 negative charges that have to be counterbalanced by the 2 positive charges on calcium. Now that they are dissolved in water, we have to show AQ and AQ for the ions. Okay. All right. Now that we know what happens with sulfuric acid in water and calcium hydroxide in water, next step is to write the reaction between them. Oh man. Okay. So reaction between sulfuric acid in water and calcium hydroxide in water. Let's start with the molecular equation. So we have here H2SO4 plus CaOH2 always we are going to form a salt and water. So let's start writing the water here. The salt is going to be formed by the first element from the base, calcium, combined with the oxo anion from the acid, sulfate. Okay. Careful here with the charges. Calcium, we know that this is 2+, and for sulfate, we know that is a 2- anion. Every time you have the same charges in an ionic compound, they can be canceled. So we don't have to cross any charges. And the formula of the salt is just CaSO4. At this point, we are almost at the end. Now we need to verify if the salt is soluble in water or if it is not soluble in water. So go back to the solubility tables. Let's look for sulfate. And sulfates are going to be soluble except when bonded to calcium, for example. So we know that calcium sulfate is therefore not soluble in water. So we are going to indicate that by a solid between parentheses. Okay? And that indicates the formation of a precipitate. So if we start with a solution of sulfuric acid and calcium hydroxide, mix them together, we will visually see the formation of a white precipitate, and the identity of the precipitate is calcium sulfate. It's a salt. Okay. Now let's just balance the equation. So calcium and sulfate are already balanced, and we just need to balance the water here with a number 2. Okay, and that's what you got for the molecular equation. Any questions at this point? Okay, if there are no questions, let's move on to the overall ionic equation. Okay, for the overall ionic equation, the trick here is to first write the reaction between sulfuric acid and water. We already did that, and we know that this forms H plus and SO4. The number of H plus is equals to the number of hydrogens in the formula, and the charge of the sulfate is 2 minus to counterbalance the 2H plus that we have here. And let's do the same thing for calcium hydroxide, CaOH2. Let's dissolve that in water. So we are going to form calcium and OH minus. Okay. Dissolved in water and dissolved in water. We started with 2 OH ions. We have to finish with 2 here. To counterbalance the 2 negative charges, calcium has to be 2 plus. Now we react. Okay. Positive is going to look for the negative. That's going to form calcium sulfate. We know that calcium sulfate is a solid, therefore will not split up in water. That's how it will show up in the equation. And same thing here, positive is going to look for the negative and form water. Okay. Then we can use the stoichiometric coefficients from the reaction above, and it's simply a 2 for the water. Now for the net ionic equation, we may cancel if an ion shows up in the reagent side and on the product side. In this case, everything is different compared reagents and products. Therefore, the net ionic equation is going to be exactly the same as the overall ionic equation. Okay, so we just repeat everything because nothing changes. And that gives you the net ionic equation. Okay, did you get it? I hope so. And that's how you react acids with bases. So now we know all the ways to write the equation: molecular, overall ionic, and net ionic equation. Okay? So chemists are always looking for a precipitate. Why?
To prove the chemical reaction happened.
That's a good point, Katie. Thank you. Always, precipitates are super easy to separate because filtration is one of the cheapest techniques and you can easily isolate your product. So especially if you're running an industrial process, if you have your final product as a precipitate, that will decrease the costs of production. Because filtration, again, is pretty easy to do, easy to isolate the product as well. Okay, very good. So with that being said, so let me go back to the normal flow of the lecture. Okay. Let's see here where we stopped. Okay. So reacting an acid and a base is a way to produce salt and water, usually a precipitate. Okay. However, there is another way to produce a precipitate, and that's reacting a salt with a salt. So let's see here one example for the reaction between lead-2 nitrate and sodium iodide. So when you mix up lead-2 nitrate and sodium iodide, you're going to get a very beautiful precipitate here, bright yellow. Chemistry is very colorful, very beautiful. Okay. And that tells you that something happened in the reaction. Okay. Our job is to identify what exactly is going on in the reaction. Okay, so let's start by writing the formula of the salts. For the lead-2 nitrate, you don't have to know that, but that's going to be Pb2 plus. So the 2 here indicates the magnitude of the positive charge. And then we have nitrate, which is 1 minus, crossing the charges. This is PbNO3 2. And sodium iodide, this one you have to know, sodium 1 plus and I 1 minus. Okay. So now let's react these two salts and see what happens. Starting with the molecular equation, let's write here PbNO3 2, and that's dissolved in water. So we need to represent AQ. And the same thing with sodium iodide. Okay, this is dissolved in water as well. Every time you have a reaction, the positive is going to look for the negative and vice versa. Sodium is positive, therefore is going to look for the other negative, which is nitrate. And they are going to combine and form sodium nitrate. 1 plus, 1 minus, does not need to cross anything. And lead is going to look for the other negative, which is iodide. Lead is 2 plus, iodide is 1 minus, cross the charges, we end up with PbI2 here. Don't need to write 1 as a subscript for the lead. Okay, so now let's go back to the solubility tables. Let's look for nitrate first. So let's go all the way back here. Nitrate is right here. Nitrate always forms soluble salts, so that doesn't need any thought. Now let's look iodide. Iodide is soluble with the exception when combined with lead. Therefore, we know that we have a solid here or a precipitate, and for sodium nitrate that still is dissolved in water, is aqueous. Okay? So that's the identity of your yellow precipitate, is lead iodide. And this is why the reaction happens, because it forms a solid compound which is more stable than the compounds dissolved in water. And that's the driving force of any chemical reaction. Okay, when reacting salt with salt, always look for positive combining with negative and vice versa. Check the solubility and indicate if there is a solid or not. If there is a solid being formed, there is a high probability that the reaction will happen. Okay, so now let's write the overall ionic equation. The overall ionic equation, you have to write the reagents as ions. So let's start with lead nitrate, and let's dissolve this in water. Nitrates are always soluble, always soluble. Therefore, when you dissolve the solid in water, the water is strong enough to break the interaction between lead and nitrate, and that's going to produce lead 2 plus AQ and nitrate 1 minus AQ. Attention here, we have 2 nitrates to start with. We have to have 2 at the end. And we do the same thing for sodium iodide. Let's write sodium iodide. Let's dissolve this in water. Iodides are soluble when combined with group 1. Therefore, the water is strong enough to break the interaction between sodium and iodide. It's going to form sodium plus and iodide minus, dissolved in water. Now that we have the ions split up, let's combine positive with negative and vice versa. Sodium is going to look for nitrate. That's going to form the sodium nitrate. Now pay attention here. Sodium nitrate is soluble in water. Therefore, in the ionic equation, if they are soluble, we have to write them as separate ions, okay? Again, if the salt is soluble in water, when we are writing the ionic equation, we have to split the salt in the positive and negative ions. Okay, sodium nitrate in water always going to be found as sodium plus and nitrate minus. Lead will combine with iodide. When lead combines with iodide, we know that a solid is formed. Therefore, water is not strong enough to break the bond. And then we write PbI2 and indicate that this is a solid. Okay, so that's now the overall ionic equation. And now to write the net ionic equation, we can cancel everything that shows up in both sides, like treat the reaction as a mathematical equation. Starting with Pb2 plus, look to the other side and you have to find exactly the same thing, okay? On the reagent side, we cannot find Pb2 plus by itself. Therefore, we have to write Pb2 plus again. For nitrate, the reaction is not balanced out, but doesn't matter. You see nitrate in the reagent side and nitrate in the product side. We cancel that up. Same thing for sodium. We found the same thing on both sides. And then iodide, we cannot cancel. And the product here is going to be PbI2 solid. Then we can balance here with 2 iodides. And that's how you write the net ionic equation. Okay, every time you see a chemical reaction, the first thing is to not panic. Every time you panic, you do stupid things. So be calm, start the process, trust the process, write everything, and then I'm pretty sure you're going to get all the way to the end in a successful way. Okay. Is there any questions?
So does it not matter that there's 2 nitrate ions on the left side and just 1 on the right side?
No, it doesn't matter because you have to balance the reaction at some point. You will see that they will show up 2 and 2 on products and reagents. So it doesn't matter. Once you see the same thing, you just cut up. Yeah, so actually if you balance here, you're going to find a 2 here and a 2 here. So that will take care of everything.
Would that also carry into the overall ionic equation as well?
That will carry as well. So I was lazy here. Sorry, guys. You have a 2 here, 2 here, 2 here, and 2 here.
Thank you.
Yeah, so that's why it's always a good idea to start with the molecular and then you carry over the coefficients to the ionic equation. Okay, so every time you have a coefficient 1, I know that the 1 is there. Don't lose your time. You don't have to indicate that, okay? Save your time for more useful things. Okay, guys, if there are no more questions at this point, uh, so let me tell you one thing before. Chemistry, unfortunately, is practice, as anything that you do. I do not expect you to ace everything the first time. You're humans, okay? I was a student at some point. You will struggle, but you have to keep moving. What's in the past is in the past, is done. Cannot change it. Let's move forward, okay? Let's practice a lot how to write chemical equations, overall ionic equation, and net ionic equations, and we will ace at the end, okay? So if there are no more questions, then I think that's good enough for today. And I will see you next Tuesday, okay? So have a good week. Enjoy your weekend.
And then I know you record these. I just want to like watch this again later. Do you actually post the recorded, or are you just posting the
I'm going to post, I mean, yeah, I always post on YouTube, and then I post the link on Canvas.
Okay, thank you.
Yep.
Thank you.
Bye-bye.
Thank you.
Thank you.
Are we doing the in-class assignment next week then?
Yes, yes. We will go back next week to the in-class. Yes.
Okay.
Okay.
Yes. Thank you.
Bye-bye.